And that's what we want there. Yeah, this meeting is being recorded. Okay, so yeah, there's your results. There are the marathon results. And you're just picking as many ways as team A1 or team B1 or team C. You can mix and match. You can do all team A. I don't care. You pick and tell me why you think they won. But we'll do that in a few minutes, right? Justin, I like the way you think. Hot dog eating marathon. Oh, and Terrence actually has run. Wow, Terrence, that's impressive. That is super impressive, by the way. Nadine, awesome. Netflix marathon. I like that. Now work that into an answer and then, oh, it works. Any type of running is impressive. Half marathon, yeah, that would take a lot too. I think that mud run is the military run, isn't it? That what it is, Justin? The mud runs? It's like a mud run. Is it through an obstacle course? Is that what it is? Yeah. Yeah. Yeah.
And it gets dangerous sometimes.
Yeah.
If you fall into the mud, actually you do.
Justin, we all were. I used to do one a long time ago when I was a competitive mountain biker, and we used to do pedal and paddles, right? So we used to do, you'd mountain bike, and then you take your bike and throw it in a canoe and canoe a whole massive area, get to the other end of it, take out your mountain bike, and then do another road, like another track. That was fun. Pedal and paddles, we used to call them. Okay, Justin. I'll give you 5 more minutes and then I want to hear some of the answers you guys got.
I figured it out, but I'm not sure if it's right.
Well, there's lots of different answers, right? We're going to hear some of them right away. Well, here, you start. Give me one of your answers. What do you think?
Okay, I'm afraid you're gonna laugh. I just added together the ranks, and B's ranks were the smallest, so I'm thinking B1.
Okay, so you added the numbers with the ranking. So team A, you added a 1, a 3, an 8.
Yes,
What else? A 13. And then which one did you pick? The highest one or the lowest one?
the lowest.
Because the lower the number, the further ahead they did. That is a
Yes.
great answer. That's one. Okay, somebody give me another one.
What I did was I checked to see which team finished first. So all of team A got over, and then all of team C got over, and then all of team B.
So you looked at just the rankings here and you decided, okay, you can see the 28th position here, right? Team A made it across. So all 10 members made it across the finish line first before C and B. Good. That's another great way. Okay, give me something else, somebody else. Okay, well, here I'll ask a question. Normally in a race, you have gold, silver, and bronze. According to that, what team won?
A.
Yeah, because they got a gold and a bronze, right? So that's another variation. I could say, yeah, team A won because they got a gold and a bronze. You know, team B got the silver, but who cares? Okay. Anybody else? Top 10? Which team won according to the top 10?
C.
Yeah. In the top 10, they had 4 places, didn't they? A had 3, B had 3, but C had 4 times. So you could say in the top 10, I think team C won. It's a valid point. You see what I'm doing though? I'm just trying to do variations on different things, right?
Yeah, that's a good method too.
Here, you could also say this, you know, it's not about who wins anymore. It's about participation. So I think team B won because they came in last. You know, you could do something as silly as that. I mean, it's all about participation, right? You can have a multitude of answers. And this is a really great question in that it can really spark good conversation about ranking of stuff and placement and stuff, right? First, second, third. We could talk about averages, right? We could talk about who placed in the middle, who placed at the last, right? Yeah. Did anybody think of a funny one? Do we have any funny ones?
I thought my way was funny.
Your way was probably like the number one way to look at it. Just add up the points. Yeah. Okay. Well, we'll move on from that one. So that leads this activity, I know, kind of surprising, leads into today's lesson. Woo! It's on statistics. And I don't know if you guys read, you guys should have always been reading these, right? On the math blog every day, I post, what we're doing today, right? And this is the big one if you read this. And let me make it large on the screen. Oh, that's a little too large. Right? Here it is here. Statistics. There's right, there is wrong, and then there is statistics. That's the way it actually works. It's a big joke about statistics because the interesting thing about statistics and the whole study of statistics, if I can say it properly, is you can make data, a bunch of numbers, you can make them say anything you want. And that is commonplace. You see it on TV, you see it on the news, you see it in the newspaper, you see it on any social media, right? You can take whatever you want for data and change it so it represents what you want. Okay. Let's go back to contemporary mathematics. Oops, this is wrong set one right here. Go back to where we were.
I loved mean, median, and mode in high school.
Mean, median, and mode, you actually can start teaching that like at a really, really, really early grade. And then you continue all the way through middle years and into high school. We cover it actually in all mathematics, 9, 10, 11, and 12. It's always there. And I think we kind of like just do it so much and so much people get tired of it. But it's a really useful thing because you have to be able to interpret data in the real world. You're going to be bombarded, especially nowadays with statistics and social media and stuff like that. You're being bombarded all the time by numbers. You have to be able to identify what's useful and what's not. Okay. So let's go to the PowerPoint. And again, I think this is if I remember correctly, it's a pretty short PowerPoint. So that'll give us more time to work on questions or if you haven't finished your assignment, to get that done and ask some questions. Okay. Also, sorry, before we get going, a reminder Friday is the deadline for you to make comments on the course. I'm trying to remember what it was called, right? Course evaluation, that's it. Course evaluation. So you can go in there, there's a whole bunch of things you can rate. Please, if you're gonna talk about, I didn't really like this in the course, give me, like, you can say the criticism, but give me a response to it. Give me a solution if you can, okay? Does that make sense? Right? Like saying you didn't like the color of my shirt, maybe, Brian should wear yellow shirts all the time, whatever it was. I know that's a stupid example, but I'm dead serious. You can be critical of the course, but give me feedback. It's useful because it helps. Sorry to say it doesn't help you guys anymore, but it helps the people that take the course in the future, right?
I have a question.
Yes.
You already read the review then.
Hang on a sec. Eric. What was that, Alice?
Last time I almost forgot on my other course. Is there a penalty if we missed the deadline?
Deadline for what?
For doing your course evaluation.
You can't do it. After a certain amount of time, you just can't do it.
Oh, okay.
You don't get marked anything, like you don't get bonus marks or less marks. We don't see names, right? Nobody sees the names. It's all anonymous, right? It's just once it's finally cut off, it's cut off. And I don't understand why they cut it off on Friday because we still have a course next week. I don't know what they're doing. Okay, Eric, you had a question or comment? Sorry.
Oh, I was just trying to be funny. I said you've already read my review because of your shirt comment.
Did you actually put that on there?
No, I didn't.
Oh, damn. That would have been incredibly funny if you had done that. Okay. Let's do statistics. By the way, I think of all the units, statistics is my favorite. I don't know why. Maybe because you can manipulate math so much with statistics. Okay, slideshow from the beginning. Okay, so kind of the main thing about, before we get to mean, median, and mode, one of the main things that we have to cover, and this is going to be social media, and your kids, like your students, when I say kids, are going to be looking at this all the time, is how you visually represent data. And we do this by graphs, and there are tons of graphs, and you can make graphs say whatever you want depending on how you lay it out. Okay, so let's take a look at this one. So organizing, and hang on, I got to get this other screen here. Sam, I can't see it on Moodle. It's because we don't use Moodle, Sam. Hey.
No, I've got it. You just have to go on on the main brand new page.
Oh
Go
yeah.
on like tax receipts, and it has everything else there as well. So.
Oh, okay, cool. Yeah, I don't use Moodles. Oh, there, it's in student information. There we go. Okay, so here we're gonna just, I think hang on here. 1, 2, 3, 4, 5, 6, 7. Like the next seven visual representations are all just different types of graph, right? So one of the main things we do is dot plots. This is kind of the common way you can do this. And this is nice, you can work with kids, right? You could measure the height of kids in class. You could talk about a number of siblings that they have, a whole bunch of different variations, right? So this one's called a dot plot. And a dot plot is just a line at the bottom, and then we put dots where we represent numbers. So this one are final examination scores in for elementary school teachers, whatever it happens to be. So you can see, and you can look at these dot plots right away, and you can see where's the bulk of these scores. Where's the bulk of these scores? Nobody?
Between 75 and 80.
Okay.
Or I guess we're on
No,
80.
that's perfect. So you said 75 and 80. Does anybody think it's different? By the way, it's okay to think differently. Okay. Well, I might say between about 62 and 80. I think that's a big block. Somebody might say between 62 and 95. That's a big block, right?
Yeah.
There's lots of answers, and that's why statistics are so interesting, is depending on how you look at it personally or what information they give you, it's different to interpretation, right? Okay. That's a dot plot. Another one, same scores. We can do this, what's called a stem and leaf plot. Okay. So a stem and leaf plot, I don't know if these are not as common. Some of you may have used them, some of you may not. So what you do is down the left side, right, is you represent the 40s, the 50s, the 60s, the 70s, the 80s, and the 90s. And then this second number represents like this. So this first one would be 49, right? The second one would be a 53 and a 58. The third one would be 62, 63, 64, 65, right? You get the idea, right? So in this case, you can see, oh, look at all the numbers in 60s and look at all the numbers in 70s. That's a big chunk right there, right? And again, it's just interpreting how you look at the data. Who is that? Thanks, Holly. And yeah, okay, yeah, she's been having trouble with that logging in for some reason. I don't know why. Sorry, I'm just checking on attendance as people are talking to me here. Okay, so that's stem and leaf plot. Right, it's the same set of data. Okay. Then you can represent stuff with the good old histograms. Histograms are frequency. And if you notice histograms, some of you say, oh, no, that's not a histogram, that's a bar chart. There's a big difference between that and bar charts. Histograms are joined together, right? So if you look at here, we have a range, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, right? You can see and you can break up that frequency however you want. You might have seen this before when they you might have remembered normal distribution. Have you ever heard of that? Normal distribution? It's interesting when I I used to do this all the time when teaching classes, like in at high school. I would take my students' marks, let's say in a math course, and I would plot them out. And you get what's often referred to as a perfect bell curve. We're going to talk about them later on, like about 20 slides in. And I found over the years, I'm getting less of a bell curve and I'm getting a double bell curve. So I'm getting a bunch of kids that sit about at the 50 mark, right? Because they do just enough work to get through the course. And then I have another group of kids that really want to do well, and they're in the 80s and 90s. And there's barely anything in the middle anymore. And I've seen it over the years. It's kind of interesting as a math teacher to look at that. Okay, so that is a histogram. Next one, bang, line graphs, right? Or frequency polygons. Again, there's that stupid word. Why were they using polygons for that? Makes no sense. So line graphs, this is one you would use like for temperature, right? So you would show the temperature over the course of a week or daily, right? You would have it, midnight, 1 a.m., 2 a.m., 3 a.m., and you could watch the line graph move around. If you actually have the weather app, and I have, where's my phone? I have, what's the weather app on my phone? Oops. The Weather Network app, right? I can look at it right now. I got my phone here. If I go there and I can look at, where's the graphs? Charts. Go to charts. There. No, this one's kind of a bad one, but I can hold it up. So there's a good example of line graphs on my phone, right? For talking about temperature. Oh, this is wind during temperature, whatever it happens to be. It's a super common one. You will see line graphs all the time. And there you can see here, the highest point here, inches, but you got to look on this side, frequency. That means how many times it occurs, right? So this one at 69 inches here is probably about 20 times, right? 68 might be about 50. Sometimes it's a little bit hard to see, okay? Line graphs. Here's your bar graphs. Bar graphs are when we break it down. So for instance, this could be grades in a course, F, D, C, B, and A. And you can see the frequency, right? Most of the people in this one, what is it, about 14 people got C's, and they got our B's and A's. This is often what you will see as a normal curve distribution. But the difference is it'll be a histogram because it'll be joined together, whereas bar charts are broken apart. Okay. This next one, probably the most common graph ever used. Pie charts. You see pie charts everywhere, right? This is really interesting. Look at this one. This is actually pretty close to being real, by the way. So this is represent the amount, what does this represent? Percent of each tax dollar expended by Milehouse School District. So here's the deal. School districts, the bulk of the money always goes to pay who? The teachers. That's true in all school divisions, right? They actually spend very little on maintenance or administration, and sometimes very little on upgrading the schools, right? The bulk of dollars spent is always on teachers. Most teachers would say that's not true. They spend the least amount on, no, it's actually they spend the most amount on teachers. But pie charts are really useful because you can actually do it by percentage, because everybody knows that a whole pie chart is 100%, and they can see right away very easily. Look at this blue section here, 75%. Wow, that's massive, right? But again, you can portray different information different ways. If you move some of these colors down to the bottom, you can make the blue stand out even more, right? There's lots of ways of doing that. Okay, and the last one of these 7 graphs, and again, there's more than this. These are the most common ones, is the old pictorial graph. I love these ones. These ones are really kind of cool. So these are the ones you'll often see. Do you remember, did you ever look at the Consumer Rating magazine or Consumer Ratings? And they rate things like an open circle, half it with a black circle, a full black circle, a red circle, half a red circle. Like there's all these categories, and what they do is they represent how well something performs, whether it's above average or below average. Well, this one is about favorite pizza toppings. So you always have to look at the key first in any of these instances. So every one of these little pizzas here represents 2 votes, okay? So vegetables, how many votes did vegetables get? I think somebody said it. I could barely hear you.
One.
One,
One.
right? Because it's half a pizza, it's one, right? What about pepperoni? What's pepperoni?
11.
11. Pineapple. Do you see pineapple on there, Justin? They could put poison, right? Poison, and then they could have like, I'm joking. I love ham and pineapple. It's my favorite pizza, by the way.
So you're
Pineapple
one
would,
of those,
sorry, what was that?
so you're one of those haters.
No, I love ham and pineapple is my absolute favorite pizza.
Ryan, who will make me to laugh when the scores will end?
The scores for what?
When the scores will end.
Okay, so those are just random. I mean, those are really interesting ways of doing graphs. So for instance, pictographs, you could do about car sales. You could have little pictures of cars, right? You could do all sorts of things, little diagrams, right? I've seen one done with coffee, like coffee consumption all over the world in different countries. And they have the country, and then they have a certain number of coffee cups, like coffee cups. So there's lots of ways to portray that. This one, if you're teaching stuff at early and middle years, could be really fun, right? Because they could draw the little pictures of whatever they wanted to represent, right? That would be a fun one to do. Okay, now to move on to the next level is then, well, how do we talk about statistics mathematically, right? And that has to do with measuring the center of a bunch of data. And what they call this is the measures of central tendency. That's the main encompassing thing that they talk about, measures of central tendency. And there are a bunch of them. The three common ones are mean, median, mode, the three, right? Those are the common ones. There are more than that. So here we go, mean. Mean is just the average, right? You take a bunch of numbers, add them up, divide by whatever number there are, right? The median is the one, when you arrange them, and this is the key thing, when you arrange them from smallest to largest, it's the one right in the middle. And I always explain to kids, you know, when you're driving down the road, there's this thing that's in the middle of the road, you know, where sometimes the curbs are and there's grass and there's trees on it. It's called the median. It's in the middle of the road, right? That's what this is. If you have a bunch of numbers, the median is the one right in the middle. Okay. The mode is the one that occurs most frequently. Okay. And we're gonna, I think we do examples of these coming up, and I'll give you more examples coming up. But those are the big three: mean, median, mode, the three M's. Okay, let's talk about mean. And we're gonna talk about the calculations. Okay, so the mean, this is the fancy way, X bar S divided by N. So the mean or average is a collection of values where S is the sum of all the values, right? So you take your big list, add them up, N is the number of values, and you do that. Now, oh, here, I'll tell that. So the biggest mistake, and you're gonna see this, some of you guys are gonna do this, and I'm warning you now. If I give you a question where you have to calculate the mean, and let's say you're using your calculator, you're gonna go this plus this plus this plus this plus this divided by this, you're gonna get the wrong answer. Because the calculator will do the division first and then just add it to the other numbers. So when you do a calculation, so for instance, this one here, 7 plus 5 plus 7 plus 3 plus 8 plus 6, you have to add all those up, then hit equals, then hit divide by 6. I know it seems like a silly thing, but I see that mistake all the time in mathematics when we're talking about average or mean, okay? So let's say you're doing this with kids. Here's the interesting thing. 7 plus 5 plus 7 plus 3 plus 8 plus 6, you can show them mathematically, right? But with these cubolinks, you guys ever use cubolinks? They're the little blocks that have like a circle and then have a little piece protruding. You can stick them together, right? Use them for building and stuff like that. Look what happens when we do this. We could take different cubolinks from, like, let's say that we take some of these purple ones and stick them other places. You can actually balance them all out. So they work out to be an even thing. So here is a manipulative or visual representation of mean. Mathematically, it's 36, right? When you add up 7, 5, 7, 3, 8, 6, add all those up, right? Hit equals and divide by 6. then you can show the mathematical version of that. So it's really kind of neat. You can do the mathematical for your kids that really understand it, and then you can show the visual or pictorial representation for kids that are struggling with it.
Wow, I love this.
Most people have never seen it done that way. Most people just teach them, take all these numbers, add them up, divide by that. But kids don't really understand what the heck that is. It's just a formula, right? That's all it is. Okay. It's a really neat way of doing it. And Cubalinks you can get all over. Well, most schools will have Cubalinks, or you can use anything as long as you stack them up, right? Okay, so that's the mean. The median. The median is the one in the middle. Now, but there's a problem. You could have an odd set of data. So for instance, if you had 5 things, right? The median is the easy one because they're odd. The one in the middle is really easy to pick out because there's 2 on that side, 2 on that side. But what if you had 4 things? It's even. Where's the median? It's somewhere between these 2, right? So what it is, it's actually the average of these 2 here. Now we'll do an example right away, right? So when you're talking about median, you have to look at the middle and you have to deal with whether it's even or odd. And the first thing you have to do always is order them from smallest to largest because it won't work otherwise. So here's our data set. 24, 25, 25, 27, 29, 31, 32, 34, and 37. So how many numbers do we have even or odd here? 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh,
We have odd. So this one should be really easy, right? Because it should be then, the n is odd. So we can look, it's the one right in the middle. So on a question like this, we could say the median is 29. Okay. Data set 2 here. We have, the numbers are smallest to largest, but I think we have 10 of them here. Is that correct? So the median's a little bit harder to find. So what it is, it's somewhere in here, right? It's between 44 and 46. And some kids, and you guys, will be able to pick that out right away because what's between 44 and 46?
45.
45. But if you didn't know that, if you couldn't see that math that way, you can do it mathematically. Yep, I need to find the average, which means add those 2 together and then divide by 2. So 44 plus 46, right? We get our number and then we divide by 2 and we find out it's 45, right? So there's the 2 ways of doing it. Either visually, you just look at it and pull it out, or do it mathematically. Okay. Median. Mode. Mode is the one that occurs most frequently. Let me give you an easy example of this. Have you ever been to a bowling alley? Yeah?
yeah.
No? No? Okay. When you go to the bowling alley, you have to get a pair of shoes from the, to wear on the lanes, right? They have special shoes. They have leather on the bottom. They don't scuff anything up. Here's the deal. What if the bowling alley only carried 1 pair of each size? Would that be an issue? Yeah.
If you actually want customers to come, yes, it's an issue.
It's going to be an issue, right? So what bowling alleys do is they carry of whatever the most popular size is, they'll carry the most of that. So for, let's say, men's shoe, it might be a men's 10, right? And they'll carry the most number of that. Women's, it might be a women's 7 or 8, right? Remember, because numbers are, wait, is that right? I forget how shoes work. Anyways, the other thing is, for instance, let's say you're buying t-shirts for your school. Do you order the same amount of small, medium, large, and extra large? Do you order the same amount? No, you order the highest amount of the one that everybody wants, the one that everybody needs, right? So it's the frequency, right? So mode is used all the time. You just probably don't think about it. But let's do an example here with a bunch of numbers. So what we have here is we have our list of numbers and which ones occur most frequently.
47.
Okay, what about 42 and 44 though?
They're less than 47.
Okay. So 42 appears twice, 44 appears twice, but 47 appears 3 times. So that is the mode. It's the one that occurs most frequently. Now, could you have more than one mode?
Only if it's a tie.
Only if it's a tie. So for instance, in this example, let's say we had 347s and 344s, yeah, you can have a dual mode. And you'd say, yep, the mode is 44, it appears 3 times, and the mode is 47 appears 3 times. Now, what if everything only appears once?
And there's no mode.
There's no mode, right? So if you have a list of numbers and nothing appears more than once, you have no mode. Okay. So mean, average, add them up and divide by the number. Median, the one in the middle. If it's odd, it's the one in the middle. If it's even, it's the average of the 2 in the middle. Mode, the one that occurs most frequently. You can have more than one mode, and you can also have no mode. Okay. Those are the 3 big ones. Those are the 3 you can start teaching in grade 1. Now, there's other ones. Remember, because this is all measures of central tendency, whatever the centerpiece is and how it varies around it. So the 3 big ones that we're going to talk about, well, we're going to talk about 4. Yeah, because we got to talk about outliers. Okay, so we got, oh, data says 47. Okay, range. Range is the difference between the largest and the smallest, really common. So, right, if you had a 20 as your lowest and you had a 40 as your upper, right, the difference would be 20 because you just subtract. Okay. This is one you're probably not used to unless you have taken statistics before. It's called quartiles. Quartiles are really helpful in figuring out data that shouldn't be there, right? So quartiles, if you have a bunch of numbers, basically quartiles, just like it says, is we're going to divide it up into quarters. That's what we're going to look at. And we're going to have an upper quartile and a lower quartile, right? So we divide it up into data, okay? Standard deviation. Okay, and I'm going to talk about standard deviation a little bit. We're going to go through like these. We're just introducing range, quartiles, and standard deviation, and then we're going to actually do some work here on these. Okay. Standard deviation. Sorry, go ahead.
Can you explain again what quartiles is?
Quartiles is if you had a bunch of data, whatever the data is, you're going to break it up into quarters, right? So you cut it in half first, right? So you have half low, half high, and then you take each of those and cut them in half again. So you get a quarter low, quarter medium high, and then a quarter high, right? It's another way to look at it. And there's one specific reason we do it. And it's the only reason we do it. And it has to do with something called outliers. Okay. So I'll explain it to you in a second. Actually, okay, so then, you know what, I'm going to take this out next year if I do this. We're going to talk about upper quartiles and lower quartiles. This is kind of it's kind of silly to understand. The best way is to show you by example. That's the next slide. So just let me look at this. So here's our data set. Okay. Oops, I need to be on the right page. So the first thing we got to do with this data set is to do what?
Put it in order, smallest to largest.
Perfect. That's always you have to order the values, right? So you order the values from smallest to largest. It's the common thing. Now, what we want to do is we want to split this up into quartiles. So we need to look, we're going to split this up into 4, and each of those 4 pieces have to be even, right? There is when you can do it without even, but so if you look at this, if we break this up into quartiles, right in the middle, bang, right? So if you look, we got 0, 5, 7, 8, 9, and 10. That's 6 values below. And we have 11, 11, 12, 14, 15, 17. That's 6 values above. So we just cut that right in half. What the heck is that called? The number that's right in the middle?
Median.
It's the median, right? And you can tell by the little X with the hat on it, right? That's the fancy term for median, right? So that right there is the median. So we have half below, half above. Now we want quartiles though, right? So we got to take each of these blocks of 6, right? 0 to 10, break it in half again. 11 to 17, break it in half again. So here we go. So the lower quartile will be between 7 and 8, right? And how do you find 7 and 8? Between 7 and 8, you add them together, divide by 2. So the lower quartile is 7.5. The median is 10.5. And then if we want to find the upper quartile, it's 12 plus 14. It's halfway in between those. Okay.
Huh? So
Sorry, do you have a
what's the
question?
purpose of this
Sorry.
data?
I'm getting to that. Hang on. Like I said, the quartile is only for one purpose, usually only. It's to deal with the outliers, and I'll show you that. Okay,
That's what's left.
Sorry, what was that? Somebody said something. Oh, okay, never mind then. Yeah, Sam, that was in core math. That's part of it in the core math course. Okay, so with the quartiles, what you can do is you could find out the interquartile range. We know what range is, right? Range is the largest minus the smallest, correct? That was what we said before for range. Well, with quartiles, the interquartile range is the upper quartile minus the lower quartile. Okay. So for instance, on that last example, the upper quartile would be 13, the lower quartile would be 7.5, right? And then we could subtract the two. We're going to do another example coming up. Okay. Now, once you find the interquartile range, it is used for one thing and one thing only, for what we're going to talk about. And it's called the outlier. And what it is you take the interquartile range, and this is, you get the formula all the time. And I don't, by the way, I'll double check there. I don't think I put any mathematical questions on the final exam on this, right? It's just general knowledge about statistics. On the final exam, you will have to calculate mean, median, and mode though, right? So you're clear on that? Mean, median, and mode. But I don't think I ask any questions on quartile range. The purpose behind this, as you'll see right away, is to deal with this outlier. So what it is an outlier is exactly like what it sounds like. It's a piece of data that's hanging way out there, way out on the data set. So what we can do is we can find the lower quartile minus 1.5 times the interquartile range, and we can do upper quartile plus 1.5 times the interquartile range. Okay, it's just a formula. That's all it is. What we're gonna do is we're gonna do an example now. But let me give you why this is important. You guys were complaining before about, you're watching hockey and there was the yelling at the Maple Leafs and the yelling at the Habs, right? And now it's the yelling of the Jets as opposed, right? When you look at hockey statistics, there is one person out there that's an outlier. Does somebody want to take a guess who he is?
The lowest guy.
Correct.
It could be the lowest guy, but it could also be the highest guy. And when we're talking about hockey statistics, right? Gretzky, that is dead on the money. If you actually plot statistics, goals, assists, well, penalty minutes would be down the low, right? But all that stuff, if you plot that stuff out, there is one guy that is way out on the top end, and it's Gretzky, right? He throws all the statistics out of whack. So he's considered an outlier because he was just so good. So what happens is sometimes when they're looking at data and they want to find out, let's say the average goals over the last 50 years for a person or for a team or whatever it was, they'll often take Gretzky right out of the statistics, right? Because he's such an outlier. It's just super common. And if you look at stats, I mean, there's things like even with basketball, looking at Michael Jordan, right? Or looking at who had the most rebounds, or baseball, right? Looking at stuff like that. They often will take out outliers. Okay, let's do an example. So the example is a couple things here. So here's the data set. Okay. So we got to calculate a couple things. We got to calculate the median. We got to calculate the quartiles, the interquartile range, and then we can calculate the outliers. But what's the problem here? What's the first thing we got to do?
Order
them from
least to greatest.
least to greatest, smallest to largest. Doesn't matter. Perfect. So here we go. So the first thing we do is, wow, they did it on a plot here, which I really don't like. Doesn't matter. So we do it on the plot, right? How do you find the median? Well, if you were to do this, just hang on a sec. So they did it on a plot there. I would actually just do this on a straight line. And here's the deal. If you get into really large numbers, you'll probably do this on a program like something like Excel, right? A spreadsheet. But if you were doing this with kids, you'd probably pick smaller numbers. You wouldn't pick 24 numbers. Okay, so we plot them out. Okay, so how do we find the median? It's even numbers. So is the median going to be right in the middle?
No, we'll have to find the number between the two numbers.
Right,
in
and
the-
so if you had them listed out, the work is up here anyways, right? Actually, the two middle numbers are 76 and 76. So you add those together and divide by 2. I don't know why you would do that because the median would then be 76, right? Hey, what number is between 76 and 76? Well, that would be 76. Okay, right. So we have all the numbers. 76, the one in the middle, is our cutoff. That is our median. So there's going to be 12 numbers below it, 12 numbers above it, right? So here's our first 12 numbers. These are the 12 numbers that are below the 76. And these are then, just ignore the quartile for a sec. There's the second set of numbers, which is the 12 numbers above the 76, right? Because there's that first 76, there's our second 76. Whew, had trouble with that one. Okay, now that's right in the middle. Now we have 12 pieces of data in the first set. We need to break this up into quartiles. So we need to find where there's 6 below, 6 above, right? So if you look, you can see the picture right here. The 46 to 71 is 6 below. The 71 to 76 is the 6 above. So the lower quartile, okay, what's between 71 and 71?
71.
71, you can see that. Okay. Upper quartile range, 76 to 77, and then 79 to 92. So all we've done is taken this 24 pieces of data, broke it in half, that's the median. Take the lower ones, find the lower quartile. Take the upper ones, find the upper quartile. Now this one, a little bit trickier. Hey, careful. It's between 77 and 79.
78.
78, right? You can see that. Okay. So now, remember what we got to do. We had to find the median. We had to find the lower quartile. We had to find the upper quartile. The next thing is to find the interquartile range, which is basically 78 minus 71. That's it. It's the upper quartile range minus the lower quartile range. And again, like I said, the only purpose of doing quartiles is to figure out the outliers. Okay. Now, then what we do, we have to find the outliers. So we do some calculations, and these are just the formulas, right? The lower quartile minus 1.5 times the interquartile range, the upper quartile plus 1.5 times the interquartile range. It's a tough one to say over and over again. So here we go. We do the math. So 71 minus 10.5, 60.5 for the lower end. Upper end, 88.5. Okay. So why do we do this? Do you think I'm just trying to make your life miserable? Well, yes, a little bit of that, of course. That's part of teaching, yes. And so, no, but what am I trying to do? I'm trying to find out where the outliers are, where I cut off the outliers. These are my cutoffs. The low end, 60.5, the upper end, 88.5. So when we look at the data set here, right? Basically, 60.5 falls right into here. 88.5 falls right into here. So 90, this is what's considered an outlier. 92 and 46 are considered outliers. So in the future, if we were to do some calculations, we might not want to include those numbers. Outlier 46 gone, bang, 92 gone. What it does, it gives you better statistics. That's the reason we do this. If you take off some of the weird extremities, right? Like for instance, if these were test scores, somebody might have done really, really poorly on the test, 46, and somebody might have done really, really well on the test, 92. And they're going to skew the results. Okay. Does that make sense why we figure out outliers? It is a lot of work, right? And you know what? I'm going to check. Give me 1 sec. I'm going to check right now, just so you know for your own peace of mind. I haven't looked in a while, so I can't tell you. Just give me 1 sec here. So here's a question that's on the final. Hey, given these test scores, find the mean, median, and mode. There's a typical one, okay? I'm just looking for quartiles here. Give me a sec. I just want to make sure if I did or not. Oh. Oh, there's a pie chart. Hey. Nothing there. I'm almost done. Just give me a sec, guys. It's better for you if you know it, because then some of you, if you don't understand it as much, then it's not a big deal because I'm not testing you on it, right? No, there's nothing on that. Yeah. So if you want, this is going to sound stupid. Hey, if you want to, just ignore what I said. Well, quartiles. I think it's quite interesting. So, okay. What are we on here?
I've got a random question.
Yes.
I'm taking a statistics course next year. Will it be very similar to this stuff?
Oh, it's going to be tons of this, but you're going to expand it more, right? And let me show you what the stuff I'm showing you is like, it's like an introduction. It's like a little teaser. You're going to talk about all this stuff, but you're just going to go more and more and more in depth, right? Because then you'll talk about samples and populations and how averages and other stuff vary based on that. Okay. One of the common things in statistics also is when you're dealing with numbers is you deal with something called a whisker box and whisker plot or whisker plot. Okay. So what it is, it's a central box extending from the lower and upper quartile. So it has to do with this stuff, Alice, this quartile stuff. You'll see this coming up. Otherwise, you won't see it anymore in statistics other than that. And what it is, well, here, it will just show you the picture. So what you have is lower extreme, lower quartile, median, upper quartile, upper extreme. And what it is, it's a breakdown. Here's our box plot. And you can see this bottom piece is your whisker and box plot. And so what this shows you is just shows you a visual representation of where the bulk of the data is, right? And you can see right here, it's in the 70 to 79, and it also shows you your outliers, right? And all it is, it's a pictorial representation of 5 numbers. And you can see the 5 numbers, right? Lower extreme, lower quartile, median, upper quartile, and upper extreme, right? Okay. Yeah, Sam, I know that. She's had it up since like a couple days ago, I think. Okay. So that's box plot. Now, again, I'm not going to ask you a box plot on the final exam or anything like that, right? It's just for your purpose. That's one representation. Once you do quartiles, you can often do it. Okay, now, this one is extremely important. I'm not going to get you to calculate standard deviation. No, don't worry about it, Sam. I want you to understand standard deviation. So here it is. Standard deviation, and at one time, you might have done this. For some of you that went through high school, you might have done this calculation. Does anybody, by show of like thumbs, did anybody ever have to calculate standard deviation in high school? Anybody? You probably have to be a little bit, I hate to say it, older. I'm just joking. Right, it was a nasty little calculation, right? Remember, you got a bunch of data, you had to find the average, and then you had to find all the other numbers and then square them and then add them and then take the square root of it. Oh, it was garbage. It was a horrible thing, right? And this is what it looks like if you actually do this formula. So for instance, and this is a small data set, 35, 42, 61, 29, 39, right? You add them all up, divide by 5, you find the average. Then you take each one and subtract it from the number. So you take the number, subtract the average, subtract the number, the average, subtract the number, the average, subtract the number. Then you square them and then you add them all up. And then you divide by you divide by the number of items, which is 5. Then you take the square root of it. Oh. Right? If you made one mistake in any of this stuff, it would screw up your whole standard deviation. What I'm more concerned with is what is standard deviation? Somebody want to take a guess what they think it is? It's kind of based it on the word itself.
Maybe the general change or difference between the numbers.
Okay, so that's a really good one. And you're talking about change, you're talking about deviation, right? Which is, do we know what the average is? Yeah, in this case, we know what the average is. It's what, 41.2, right? What we want to look at is how do the other numbers deviate or difference, how they fall around that mean, right? So this one, for instance, if our average is 41.2 and our standard deviation is 10.8, we can say then, like, this is basic. 41.2 plus 10.8 gives us our upper range. 41.2 minus 10.8 gives us our lower range. Okay. It's how the marks deviate around the central piece. Okay. Now, let me give you an example. So let's say you guys, you're my class. We did the first test. Okay. And on the first test, the average, I'm making this up, by the way. The average was 70. Okay. That's the average. But the standard deviation was 30. Okay. So you got that? The marks were, the average was 70, but the standard deviation was 30. Okay. Second test comes along. You guys are really consistent. The average again was 70. But now the standard deviation is 5. Okay. First test, mean 70, standard deviation 30. Second test, mean 70, standard deviation 5. Me, as a teacher, which one do I like better?
The second one,
Okay, now I'm gonna put you on the spot, Lacey. Why?
because it means you got better at teaching.
Okay, that's a good way of putting it.
No, it means that you were giving more equitable adaptations to the students so that they could all learn at the same level.
Geez, you must be in faculty of education with language like that. I'm just joking with you, but
I
you're
am.
true. You're true. But you think about this for the first one, and these are generalizations, right? These are not true forms. The first test was 70, but a standard deviation of 30. So the marks could have been, let's say 70 plus 30, 100, and the lower marks could have been 40. Wow, some people did really well in that course. They got 100, but some people got 40. They failed. The second test, 70 with a deviation of 5, the mark range was probably approximately 75 to 65, which means more people did better, right? Overall, we were a tighter group. It was more consistency, which means maybe that everybody learned the material better. The teaching might have been better. It might have been an easier concept, right? So marks can really, for instance, I could say, oh no, never mind. That's a bad example. You really got to pay attention as a teacher when you're doing this. Don't just take average marks. You know, you type it into the computer, it spits out an average at you. Oh, that was 70% for the class. Look at doing standard deviation. And most times, you can throw this into Excel. You press one button, it'll calculate the standard deviation for you. A lot of programs where you put marks, like Maple. Some of you guys might use Maple as a grading system. We use Power School in the division. Some of those programs will do standard deviation for you. Some of those programs will also graph it for you. Really useful. Okay. So standard deviation is an extremely important thing for you guys based on what your students are looking at. Okay. Does that make sense? Sorry, go ahead.
Yeah, just a quick question. It's a little bit off topic, but like just in terms of the education review that just came out, obviously a big part of that is test scores and math and language and things like that. So when you're looking at these numbers based on, let's say, strictly test scores, is there another variable or way of adding in, like, let's say you notice 50% of your students weren't eating breakfast in the morning. Is there a way to like take that data and apply it to that? Like, do you kind of, I don't even know if that's a thing. I'm just curious.
You're dead on the money on that one. It's called socioeconomic factors, right? And it's one of the hardest things, especially with statistics, is right. There's they talk about studies all the time. There's qualitative and quantitative, right? Quantitative is pure number crunching, right? Qualitative is the subjective one where you ask people their opinions on stuff and you collect other data, right? But when they're trying to look at, especially with statistics, and for instance, grade 12 math, right? You guys know this for years. When you're doing grade 12 math, there's a provincial exam at the end. And what the province looks at is and it's quite interesting. They look at what the averages for the students. They look at what school averages are, what division averages are. And none of that takes into effect socioeconomic background. I mean, it's garbage in that way. So for instance, if I haven't looked at the full review yet. If that review looks at some of the socioeconomic background, so for instance, they compare, let's say, rural schools to private schools or rural schools to inner city schools, right? If they break it down into those categories, you can kind of get a better flavor, I guess, I don't know if that's the right word, of what this data actually means, right? That is a huge issue. You have hit upon probably one of the biggest issues in education when they talk about statistics and or collecting data.
So there isn't, like, let's say, I'm just making up numbers here. Let's say the rural schools get a 5, the city schools get an 8, and then inner city schools get a 3. Is there a factor or a way that you could make those numbers comparable? Like, if these students had the same thing, this is what their test scores would actually be. Is that a thing?
Yeah, that's something we do in statistics. It's called Z-scores, right? So what you do is hang on. We're now getting into something here. We're now getting onto what's called statistical inference, right? So this is we'll talk about population and sample first, and then we're going to talk about normal distribution and Z-scores. What Z-scores are is it takes data from any background. So you could have your rural, you could have your inner city, you could have your private schools, whatever it happens to be, and it makes it the same in some ways. Not perfectly, but it makes it the same. Okay, it's coming up. I'll show you in a sec. Okay, so statistical inference is the main things is there's a big difference between population and sample, right? And this is a good example of this is when they do a census in Canada, they are looking for everybody. They are trying to contact every single person in Canada. That's a population. Now, that is expensive, time consuming. So what they'll do is they'll often then take a sample instead. So for instance, let's say at Crocus here, which is 1,200 students, I wanted to take a I wanted to ask a question about, hey, what do you think? Should we change the school colors? I'm just making it up. So should I just ask the grade 9s? Would that be a good one? No? Should I just ask? Sorry, go ahead, Nicole.
No, you should ask everybody.
Okay, but the problem with asking the entire population, 1,200 people, that's pretty expensive. But could I take a sample, proper sample? Yeah, I could ask some grade 12s, ask some 11s, ask some 10s, ask some 9s. And within that group, should I ask maybe 10 boys, 10 girls, 10 boys, 10 girls? Yeah, because if I ask maybe just the boys, they might have a different opinion than the girls, right? So you can, if a sample is properly done, right, it is a great subset of the population. So for instance, if we wanted to find out the average age of Canadians, right, we could do a census is what we do. But we could also then maybe instead, I'm going to phone or talk to 10 people in Manitoba, 10 people in Saskatchewan, 10 people in Alberta and BC and in Northwest Territories. Like, I'll do that. That may work. The key though is your sample has to be random, right? That's the key thing, right? For instance, if I'm doing and you get this all the time. If you've ever been to Canadian Tire or any of the stores, when you walk in the store, there's people there that are always going to ask you questions. They got the clipboard there and they want to ask you questions. Most of the times those aren't rample. Those are rample. Where'd that come from? Random sample. There, I combined two words together. It's not a random sample. It's actually a sample of convenience, right? The people are coming in the store. So if you want a really good sample, it has to be completely random. You put everybody's name in a hat, pick out the names, ask them questions, whatever it happens to be, right? Okay, now, when we do a sample and we do a population, we get something really interesting. We get what's called normal distribution. Normal distribution, it's amazing how well this actually works. And what it is, for instance, let's talk about the age of Canadians, right? So we could figure out the average, and this is the little mu here in the center, right? That's the Latin for mu, right? So this is average here. So we could take all of everybody's age in Canada, if we did a census, add them all up, divide by the number of people, and that would be the age in the middle, right? And that's where it normally is. And then around that, we have, if you go to the left, people are getting younger. So down the bottom here, these are people just being born. On the right-hand side, this is the people that are just dying right now, right? So, right, young people, old people, right? The bulk of the population is in the middle. And in fact, what we can do is, and if it's normal distribution, it follows this pattern, not exactly, but it can follow this pattern. So this little symbol here, the sigma, is standard deviation, right? So what it is if we have the average and we have standard deviation, if we add one standard deviation and subtract one standard deviation, that accounts for 68% of the population, right? So for instance, if we know the average age in Canada and we figured out the standard deviation, if we add one to that and subtract one, that's approximately 68% of the population. If you did it 2 times, take the average, add 2 standard deviations, subtract 2 standard deviation, that accounts for 95% of the population. And then if you do it 3 times, you end up with approximately 100%, right? Because there's always going to be those, hey, what are those things that are way out there called?
Outliers.
Outliers, right? There's always going to be the outliers, right? These are the people that are, that live to 120 or something like that, right? I don't know what the oldest is. Okay, that's standard deviation. Now, here's an interesting one. I bet you somebody knows this. This is normal standard deviation, let's say of the age of people in Canada. Was this normal distribution ever really skewed? And when I say skewed, I mean pushed one way or pushed the other.
Yes.
It actually is currently being skewed a bit. Why is that, Nicole?
Well, I don't know. Like I know specifically like for Indigenous communities, they have a huge, like their population is more younger.
Yep.
You
So
know, like,
sorry, go ahead.
Like looking back in history, baby boomers.
There it is. There's the one. I'm talking about, like, let's say Canadian population, but you're right. With Aboriginal population, right, this bell curve is skewed more to the left, right? So it's got a bigger bump to the left and less on to the right-hand side, right? Current population in Canada is the other way. It's pushed to the right, which means we have a bunch of older people in Canada, and that's the baby boomers, right? And if you don't know what the baby boomers are, right, after World War II, when people came home, they got busy, right? So as a result, did we end up with a large, massive increase in population? Yeah. Now all those baby boomers are now becoming seniors, right? So you can have a skewed mark to the right. It's interesting when I look at, even when I do marks in my class, even in this university course, I can break the marks down and I get what's called a normal distribution. Now, I don't know if you've ever heard this before. Hey, they mark on the curve. Have you ever heard that expression? That teacher's marking on the curve. Yeah, yeah. It was a common thing at one time, less more so now. And what it is, for instance, I'll give you an example that this happened to me in my first degree. I was taking a physics course at University of Manitoba. It was an extremely hard physics course. The passing grade was 40%. That was the passing grade, which means, so this average in the middle was 40. So they had to adjust the bell curve. So for instance, if you had 70, if you got a 70 in that class, you were just kicking butt, right? That was like a 4.0 GPA. Actually, whatever it is now, I think it's 4.3 now, right? And if you got a 40, you actually were passing the course. So it was called marking on the curve or normal distribution, right? It's really kind of neat how that happens. So here, this is what I was talking about. For the population, within one standard deviation, 68, and then 95, and then 99, or almost 100%. Okay. And this is what it looks like if you're talking about with standardized normal curve. So 0 is in the middle. This is 1 standard deviation. This is 2. This is 3. It's the same as when I just showed you. Where'd my thing go here? There it goes. It's the same as this with the average plus 1 standard deviation, the average plus 2 standard deviation. It's the same thing, right? It's just how you interpret it. Why are these way down here for some reason? Okay. Okay. There's the breakdown. Okay. Now, Z-scores. So what Z-scores does, and we're not actually calculating any of this. You take the score, subtract the average, and divide by whatever the standard deviation is. And what this does, so for instance, we were talking about, like Nicole, you were talking about with rural or urban or private school. What it does is every one of those ones is going to have like a standard deviation and a score. And what this does is it creates a standardized score. So what it does is it takes a lot of those extra things out. So for instance, you'd assume that a private school would have higher averages, right? Well, this will adjust it so everything is in line. So let's say with an urban school or a rural school, and it gives you a Z score that's really close to the other ones. So it can be used to get rid of some of those weird extra stuff. But as for what I know now, there is no thing that's taking in socioeconomic stuff, right? Like whether the kids are like, for instance, do they come from one parent or two parent families? Do they come from poverty families? Do they come from middle class families? Do they come from upper class families, right? Do both parents work or do both parents at home, right? There's all that where they live, whether or not they've had breakfast in the morning, right? Which is one of the main reasons why a lot of schools have breakfast programs, including our school here. We have tons of kids that come to school that this is their meal. It's sad. It's extremely sad, right? So here's what Nicole's going to do. Nicole's going to get her teaching degree. Then she's going to go on and get her master's and PhD, and then she's going to do studies on socioeconomic values and how that affects education.
Okay, deal.
If you could do that, you could write your own ticket. I mean, people have been trying it for a long time. I mean, we know, right? We know that socially impoverished families, right? Ones that don't have a lot of money or have really rough households and all that stuff. We know the last thing on those kids' minds is education, right? And it's sad. It's super sad, right? And you're gonna find it'll break your heart when you become a teacher, right? I remember one kid, and this was when I was teaching at Massey. This is just a little side note. Comes to me one day, he goes, "Mr. B," I go, "Yeah." He says, I'm gonna have to miss class a couple times, and you know, can you give me can I have some extension on my assignments? I said, "Why is that?" He says, "I had to move out." I said, "Why?" "Well, both my parents are alcoholics, and I couldn't take it anymore. I had to get a job, and I just got an apartment, and I'm moving out." I'm like, "Oh my God," broke my heart. Like, this kid, such a nice kid, but he was battling stuff at home, and so education was on it wasn't even on his radar, right? But he came and talked to me about that. Anyways, he did it for about 8 months, and then it just got too expensive, and he had to move back in with his parents. Yeah. Sorry if I depressed you all there. Okay.
My friend who was teaching at, I don't know, at a certain place, taking his practicum, and he came home with his heart broken too with some of their stories. And I guess that's what you do as teachers.
And the stories that will do you in when you become teachers, and well, some of you already are teaching, and you hear some of the stories of some of these kids, it's just like, oh my goodness. It's heartbreaking. And so what do you here? I know I'm taking a little side note. What does that mean for you as a teacher, right? You have to create a bond with those kids, right? Sometimes you are the normal here. That's the scary thing. Sometimes you are the normal part of their life. It's kind of scary for any of my students that I'm the normal part of their life. Oh boy, I tell you, that's kind of crazy. Okay, one last thing before we do some practice and take a break here. Percentile ranking. Percentile is really a kind of a neat thing. Percentile ranking is not just a score, right? It's how you rank against other people, right? And they use percentile ranking all the time. It's used a lot in sports. So for instance, they may say, oh, you know, this kid is ranked in the 90th percentile in basketball. That means he's better than 90% of the people. For anybody that has kids, you already know about percentile ranking because they do this all the time. When kids are born, right? They measure the height and the weight. I think is that the two things they measure? Yes, no, somebody help me. Height and weight?
And the decibels of the screams.
That's a good one. The decibels this week. Okay, and then what happens is every time you take your child back for a checkup, they measure the height and the weight at the kid, and they tell you whether or not the kid is in a certain percentile, right? Some of you might have said that, right? Oh, so weight-wise, this kid is in the 90th percentile. Good, kid's got weight on him. But when they say, like a kid that's not putting on weight, oh, this kid's in the 10th percentile, which means they need to put on some weight, right? And they often talk about that with height, right? You know, when they measure the height of the kid and they say, oh, this kid's in the 95th percentile, this kid's tall, right? That's a very common thing when you see it in mathematics. And it's all based on, right? So it's based on what's below you, right? So scoring in this, so here's the main thing. You could get 75 on a test And that's different than the 75th percentile, right? So a good example of this. I'll use Alice as an example. Alice got 80% on the test, on her first test. Pretty good. Second test, Alice got 40% on her test. Are those good marks or bad marks?
Not bad average, but not
So
the,
then a four-
No, it's not. I'm just talking about you got 80 on one, you got 40 on the other. Eric, what were you saying?
Yeah, 80 and a 40. The first one was good, but the second one I would not say was good.
Okay, well here, let me add a little more to the story. On that first test, Alice got 80. Everybody else got 100%. On the second test, Alice got 40. Everybody else got 10%. Does that change how you view the marks?
yes, compared to the others, I guess.
Compared to the others? And that's all percentile is, right? Because you can have a mark on a test, but until you compare it to everything else within the class, right? It's the percentile ranking. How much better is it than yours, right? So scoring is in the 75th percentile on the test indicates that 75% of the students had a score less than or equal to you. It does not mean you actually got 75% on the test. You could have got 90 on the test and be in the 75th percentile. You could have got 40 on the test and been in the 75th percentile, right? So percentile ranking is kind of a neat concept. And again, here's that whole thing with statistics. You can make numbers seem however you want. That's statistics. Okay. By the way, sorry, I love this stuff, by the way, if you haven't figured that out. Okay, so what we got here? We have 3.1, 3.2, 3, sorry, again, a math teacher that can't count. 13.1, 13.3, up to 13.3. And it is 6:30. So let's you guys decide how you want to do it. You can either take a break now and do your questions, or do some questions and take a break now. But we are going to reconvene with some activities at 7 o'clock. Okay, so you have half an hour. You decide how you want to break it up, right? Start with questions now, take your break, or some of you need to take a break, right? And then do that. It's up to you.
I'd go eat Chinese. Sure.
Don't tell me that. Actually, I had beef and broccoli for dinner, so it doesn't matter. I already had Chinese. Okay, so take half an hour, and I'll be back and get more water. And if some of you want to work on the assignment, if you're still working on that, feel free to do that. Not going to hurt my feelings. And if you get a chance, do the evaluation too. I'll be right back.
Heather, you're gonna use the surface area of I think it's box. So it's gonna be SA equals, I'll write it in chat.
Sorry, I didn't quite hear the last little part you said.
You're gonna use the surface area formula for the box.
Okay, thank you.
Yep. When are we pulling our prank on Brian?
What prank?
I thought first class we said we were gonna prank him.
What was that? I'm coming back. I can hear you talking.
Hey, never mind. Quiet.
How are you gonna prank me? By leaving? Hang on, what are you guys talking about here? Let me look back. Can anyone tell me how I'm doing number one? Number one to which one? On the geez, you guys.
It's okay, Brian. They explained it to me.
Oh. Okay. Oh, some of you guys sent in some stuff. Oh yeah, here we go. Oh yeah, so I don't know if you noticed, if you watched the news today, kids are remote Brandon and Winnipeg and Garden Valley, I think, till the end of June. Yikes.
Brian. Have you
What?
received my assignment?
I'm printing it right now, actually, as we speak. I got the 4 of them. Once I get them, I always tell you, I always send back got it or something like that, just so you know. I just hadn't printed them off yet.
I was sorry about the one that didn't rotate. I don't know why it did.
No, it's fine.
That's it.
Why is this taking so long to print? Yeah, I got 4 of them in just recently. So once I print them off, I always wait to print them off so I can make sure they printed off properly, because sometimes they don't. So, and then I'll send back that I got them. Tyson and Alicia here. I gotta print those ones off.
Did you all have such a hot day?
Sorry, what was that?
Did
Did you ask?
all have such a hot day as today?
Well, the problem is they've turned off the air in the school now. One of the classrooms next to me was 37 degrees Celsius in the classroom. And that's just a little ridiculous. Right now, they've turned it off. I should go get my next door guy that I teach next door has a fan. I should go get it.
Why would it turn it off?
Because they don't know how to run the system. We have new people running taking care of our building, and they can't seem to figure out. They had it when it was like 7 or 8 degrees outside, they had the air conditioning on. And now that it's 30 whatever outside, they don't have any airflow at all. I don't know what they're doing. Okay, I will be, oh, sorry, go ahead. I will,
People
sorry.
fainting.
Say that one more time.
There'd be people fainting.
Yeah, well, it's actually good that we don't have kids here because it would be too dangerous for that. Because it's not dangerous enough for the teachers, but now. I'll be right back. I'm just gonna go pick up these 4 print offs and then I'll send emails back with which ones I got. Oh, sorry, I missed that, Heather. What do you want, number 10? Or did you get help with that one? Sorry. Number 10? So there's. you did? Okay, no problem.
Does angular sectors at question 10 mean like the percentage?
Sorry, what are you talking, which, on the assignment or on the, in the book?
In the book,
On page 679?
yes.
A pie chart showing the US. No, they just, yeah, what, they just want to know the percentage. So which one were personal income tax? 35%, the blue one. Borrowing over deficit, which was 21% green. That's all they want to know is the percentage and the color.
Okay, thanks.
You're welcome. Okay, let's send out to. these people.
Brian,
Yeah,
for 14,
14 on the assignment or in the book?
on the assignment, sorry.
That's okay.
It says, find the image of the given figure under reflection across the mirror line M.
Yep. Okay, so the mirror line is right in the middle. It's the one with the arrows on the top and the bottom, right?
Yeah.
So B, if it's on the right-hand side, is now going to be on the,
Left?
correct, because it's a reflection, right? So you reflect it over that line.
So is that all I'm doing is just drawing what it would look like?
Yeah, so B and C would be on the left and A and D would be
Okay.
on the right. So you just, it's a reflection of it, right?
Oh, okay.
By question page 11, question 11 on page 679.
Question 11. The pie chart indicates how the city of Metropolis allocates its revenues. Okay.
Why do I do it with a protractor?
Yeah, it's pretty much the only way to do it. The other way to do it is if you knew the totals, you could actually just figure it out that way based on percentage, but you don't know what it is, right? Yeah, see, I mean, administration, they tell you what the percentage is, right? Miscellaneous for maintenance things. So what do they want to know? What's the measurement of the central angle of, which one's administrative? Oh, well, that's easy. Administrative is 22. Oh, and then it says use a protractor. Yeah.
Okay. I missed that.
Now you gotta be careful with a protractor because you gotta remember something. A protractor is in degrees, right? So the unit circle, this circle is 100%, but a normal circle is 360. So when you want to find the percentage, so for instance, let's say you do fire protection, right? And you measure that to be 80 degrees. You have to take 80 divided by 360, then times it by 100, right? Because the scale is, you're muted. The scale is different.
To get a percentage.
Yeah, so for instance, because degrees are 360 in a circle, if you measure fire protection as 80 degrees, you have to go 80 divided by 360 and then times 100.
Why times 100?
To get it to a percent.
Oh, That's maybe off topic, Brian, but did you hear about that bad accident in near Deloraine North in a colony?
4-year-old that fell off the,
Yes. Was it in the news?
yeah, it was in the news. They just didn't say that it was, I think they
Um,
said south, whatever, that part of Manitoba.
Where was it in the news? I'd like to read it.
Hang on. Give me a sec here.
I've been singing online today for the second time already. Just to comfort the colony.
This. Features.
Hi, I have a question.
Yeah,
I'm really struggling with the assignment.
which question in particular?
Number 11, let's find the image.
So, sorry, which one again?
Number 11?
11, okay.
No, put him back.
So what you gotta do? Oh, sorry, go ahead.
Nothing. Where am I?
Thank you, Brian.
Very welcome. So, yeah, which part of 11 are you struggling with?
All of it.
Okay, so you see the given figure there is on the left-hand side, right? Okay.
Yeah.
So what we're doing is goes through the reflection that says P to P prime. Okay.
Okay.
So
Two. Okay.
okay, and then so what it is you got to look at it this way. You can see it's on the, like, I don't know if you can see my camera, it's on the left-hand side, right? So what it kind of looks like, it's going to P prime, it's a reflection. So it's kind of over here, right? So it goes from one place to the other. What you can do, one of the main things you do, if you take a piece of paper and draw that shape, then lift the paper up off your page and flip it over and put it back down, you can usually see then that that's the reflection. Then that's a horizontal reflection. It goes left to right. Then what we got to do is we're going from top to bottom, right? So we're doing now a vertical reflection, and you do the same thing. It flips basically down below again. So like I said, if you take a piece of paper and draw that shape, flip it over there, then you can kind of see what it looks like, and then flip it down, you can see what it looks like. Even if you use something like a simple Post-it note or just a blank piece of paper, usually works.
Okay.
Give that a shot. It's if you tracing if you at home, I don't know if you have parchment paper at home. If you do a piece of that, works really well. If not, you can just use a piece of paper as long as you can kind of see through it. What time is it here? Oh, 2 more minutes and then we'll do some of these activities here. And then we can go back to if you need more time to do questions and stuff like that. I don't know where we. Hopefully the people that left, I had got attendance before that because I know the ones that said something to me, that's fine. I got them attendance, but a bunch of people had left and I hope I got their attendance. Oh, well. Okay. Where are we here? Know what I say? Yeah, 2 more minutes. Well, 1 more minute and then we'll do some stuff. Okay. So we can come back to some of the questions if you want in a bit, but I want to just talk about three things basically. One of the things I used to do when we had in class is we would do a counting colors activity, and this is a great one with kids, and I would use Skittles. And what we would do, and I'll come back to the mean, median, mode, range game in a sec, but the counting colors one. So what it was is, and I'll put up the screen or the sheet here. What it was is I bought big bags of Skittles and then broke them up into smaller bags, and I gave each table a bag of Skittles. And what they had to do is they had to count in their bag, right? So green, and then they would count how many green ones there were. Red, and they would count how many red ones there were. And purple, orange, and yellow, I think are the colors, something like that. And then based on their numbers, right, I would get them to calculate the mean, median, and mode. And sometimes there would be no mode, right? The median was always there, the mean was always there, and you'd get them to do that. Then once each group did that, I would get them to give me their numbers. So for instance, for let's say the first one was red, this group would have 10 red, this group would have 12 red, and then we'd add all those up of all the colors, and we would then create a class mean, a class median, and a class mode. It's a really good activity because first off, it's candy, right? And a lot of kids like candy. And it really gets them to understand how to work with mean, median, and mode. So you can keep the sheet if you want, right? It's just a PDF, and I've used it before. Take it and use it if you want. I was thinking then, well, one of the main things too is I was looking up trying to find activities for websites because everything's remote learning, right? So I wanted to find something, and I found this one, which is kind of neat, and it has to do with graphing. So for instance, if right under counting candy colors, there's a website here, and what it is, it's a jelly bean tree. I know it kind of seems silly, but it's actually not a bad one. So what you do in this case, and I'll hit play. So you can see there's all these jelly beans on the tree. And what you do is you pick the jelly bean off. So if I pick a purple one on, I drag it over to the purple, and it has to be in the box here at the top. And what it does is it starts filling up the bars. Right, so we can keep doing that with purple jelly beans, right? And you're basically, your whole goal is to get rid of all the jelly beans on the tree. And every time you go into this, it's random, right? So if you did this activity and then came back and did it again, you'd get a whole nother thing to do. So then what happens is, if you notice here, you can switch the graph. So this is going to be a bar graph, right, with colors, and then we can count how many on the sides. But if you switch the graph, it actually throws it up as a pie chart and then shows you, hey, we had 5 red so far at the top, 0 orange, 0 yellow, 1 green, 4 purple, and total, right? So if you can use the total to then show them how to do percentages. So let's switch the graph back, right? Give me a minute to just, if I should have, so many things on here. Trying to do as fast as I can. I just want to show you what happens once you finally finish, because it's kind of a neat, they give you some questions that are really kind of neat for the kids to look at. Sorry, my mouse pad is moving around here. There we go. Helps with your fine motor skills too, I guess, eh? In fact, if you're ever teaching kids how to use a computer and want to get them to use a mouse, get them to play solitaire, where you have to teach them how to do that, because fine motor skills are something that you can really work with, especially on a computer. I know you're really excited about me watching me play this game. You can also play it yourself if you want to, just go to the website. But I want to show you what happens once we finally finish here. And you can see it's going to create a bar chart, and it's not an even bar chart, which is kind of nice. Oops, that one didn't go in. There we go. And then the purple one. Okay, so once we do this, then what it does is it asks you some questions, and these are kind of really interesting questions. So how many total jelly beans grew on the jelly bean tree? Well, first off, you can't look at this screen, but if you switch the graph here, you can see right there, the total, right? So then the kids could go and type in 49, right? How many jelly beans were purple, right? So one of two ways, right? They could either count the purple ones on here, or on the graph here, you can see that the purple ones are 11. Oh, okay, so we can put in 11. Now, they don't ask you just general questions. They say, okay, how many jelly beans were purple and yellow added together? So now they're actually getting you to look on the graph. So purple and yellow. So yellow was 9, purple was 11. So now we can say, yep, 20. How many more jelly beans were red than yellow? So you look at red is 12. Yellow is 9. Yeah, so then we can say, yep, 3 more, right? And then how many fewer jelly beans were purple than red? So purple is 11 and red is 12. So then we can say 1. And then what you can do is you can get them to check their answers. Congratulations, you answered all. Yeah, right? It's a really kind of a neat way if you want to show, that you successfully answered 5 questions, play again to print another graph, right? So if we play again, it's going to give us a whole new graph. Kind of a neat activity if you really want to show about bar charts, pie charts, and some general questions related to that stuff. Okay, so that's one game. Now, the last game here. So that was all counting colors, and I kind of found that for the counting candy colors activity. It's kind of all related. Now, there's a really neat game here. Mean, median, mode, and range game. And this is really neat. I don't know if you've ever played skee ball. Skee ball is where you have the things and you throw the ball up, and it has to get into certain holes for points. So let me do this one. What's this one? This is abcya.com. Whoa, that's a little loud. Hang on, sorry. Hang on, let me find the settings here. Sorry about the sound. So what happens here is you get a ball and you throw it up there, and you continually throw it up and try to get it in certain spots. Okay, you just watch what happens. I'll just play this here for a sec. Justin, I'll answer your question in a minute here. I'm just doing this. Okay. Oops. Okay, so I really can't play skee ball very well. There we go. So what happens then is it goes through that and gets you your high score game over. And then what it does is it gives you a bunch of numbers. Right? And kids love games where you get tickets and you can buy stuff with the tickets. So what it does is this is round 1 of 3. And what it did is it revealed a set of data. Here's your data, right? 5 pieces of information. And in the settings, you can change it to different levels and stuff like that. So let's continue. Now, this is kind of cool. The first thing it tells you to do, right? So you can see it's highlighted. Everything else is not highlighted. The first thing you do is drag the numbers in order from smallest to largest. So you drag them, right? There it is. Perfect. And it shows that we did it. Now it's going to ask us all these things. And here's the cool thing. So find the mean. If you don't know it, you can click on this one and it tells you the mean is the average of a group of numbers. To find the mean, add up all the numbers, then divide by the number of numbers. Gives you a calculator here, right? So you can go in 1, right? Plus 10, plus 14, plus 15, plus 20. Remember, hit equals. And then we're going to divide by 5. And we put in our number. Oh, there's our mean. It's 12, and we can type it in. Median, right? If you don't know what it is, it's the one in the middle. So in this case, it'd be 14. Find the mode. Do any of these occur more than once? No. Hey, then you can click on there is no mode. And then the range, right? Remember, the range is the largest minus the smallest. So you can hit 19. So then once you're done, you can actually press check your answers. Hey, you've earned 4 bonus tickets. Right? And then you can go on to play the game for round 2, and you can just keep working through it. And it's a great activity to do mean, median, and mode, right? Mean, median, mode, and range. Okay. If you get a minute, like actually click over to the game and give it a shot. It's actually quite fun, but it challenges you to figure out what the mean, median, and mode was. Oh, sorry, Justin. See, if I ignore you long enough, you just get the answer. That's the best way to teach. I'm just joking. So if you get a chance, just roll over to that, play around, see if you can get it. See if you get a wrong answer, see what happens. Stuff like that. You can always try. But I found this game and I'm like, I was quite impressed at how well it was designed for mean, median, mode, and range. Now let's look at the settings here. Let's see what we can do on settings here. Home. Oh, maybe you can't change the settings. Okay, I think, well, let me double check here. Oops. I think that's all I had for you for chapter 13. Yeah, we did the statistics. We did the games, the counting color games, the website. Okay, so what I'll do is I'm going to stop the recording because then it can start doing its rendering. But I'm staying here if you have questions about any of the assignment, right? You can ask those questions. And for those that have handed it in and done all that, you guys are more than free to go. But here, let me stop sharing here. Let me stop recording.